And this Boston Dynamics is now developing, right, an artificial intelligence robot. Now I will tell you what is meant by artificial intelligence, right? Say for example, we have arms and payloads and others, right? So pick and place, right? I will give you the pick and place, right? Now this is a robot. It can pick and place an object from one place to other. This is the task assigned to this robot. Okay. Now we have some basic components of the robot. See, it's the base of the robot, and this is the arm of the robot, and we have an end effector. We have an end effector, or it may be a gripper. Okay, here we're calling it as gripper. This gripper is having several types. It may be a magnetic gripper, or it may be a vacuum gripper, right? We have several types of grippers. So we are using this components. This is called as robotic components. That's why I told you in the first day we're having the 3D printing techniques, and we are going to design the 3D models. Okay, okay, we are designing these 3D models, and we are going to fabricate these 3D models to form this robot, right? And we have so many interdisciplinary links in the robots, right? In this robot, you have a 3D model, so it is coming under the concept of mechanical engineering. If you are programming, then it is coming under computer science, right? See, if you're giving the power supply and the drivers, you need sensors and actuators, then it is coming under electrical and electronics disciplinary. So we have a common platform. This all disciplinary is coming under a single umbrella. So it is coming under a single roof, right? So we are going to see the basics of this robot, right? Now we have some components of the robot. So I told you already. Okay, now we are going to see about artificial intelligence robot, right? Say for example, I'm having pictures from this Boston Dynamics. We have some pictures, right? Right, yeah. We have this artificial intelligence robot. It can react, mimic like human being, right? Please watch this. It is a small video. Okay. So now you can see this is an end effector, and you see it can walk. This company is the leading developer of a robot. Okay, can you see this? Okay, it can mimic the human being. It can think and it can react. Okay, so this is a innovate link is not opened, Akash. Don't really. Okay. Okay. Yeah, it can react. This is a way they are developing, and another one robot is like this. Okay, please wait. Is okay. Yes, ad is running. Don't worry. We are having another one. Wait, stay back. We'll do. It's running. Please wait. It's in Boston Dynamics. Okay. So this robot can think by its own, right? It can mimic the human being. It is called artificial intelligence. So this total artificial intelligence is coming under the computer science umbrella, right? It is the programming part. So in this session, I will throw some light about artificial intelligence and machine learning. Did you heard about this artificial intelligence means? Then it is okay. But I'm giving the basics, right? Because if you need a huge knowledge about this artificial intelligence, then we are preparing another one internship. Then you can join that. Okay. So now in this robotics, we are using this artificial intelligence somewhat. Okay. Now we can use this artificial intelligence to think the robot by its own. Okay, now I am going to tell what is meant by artificial intelligence. This artificial intelligence, please wait. Artificial, have a picture. See, I have a wonderful picture. Please wait. So I'm going to take this versus machine learning. Yeah, machine learning. I have a excellent picture. I am not going to copy this picture into PPT, right? just I'm opening here. Like this is artificial intelligence. This total artificial intelligence is coming under the roof of computer science engineering and the programming, right? And this artificial intelligence is a subset of data science. This ML, shortly called as ML, is full form is machine learning. This machine learning is a subset of artificial intelligence. If you're having this deep learning, see it is called as DL. It is a subset of machine learning. Okay. Now I will tell you what is meant by artificial intelligence. You can program to think. Okay. Please watch carefully. You can program a machine to think by its own, right? Then it is called as artificial intelligence. If you are teaching a machine to think to a certain level, right, to a certain level, then it is called machine learning. If the data is more complicated, if the data is very high, then it is coming under this deep learning umbrella. Okay, so we have several techniques in programming. It is a vast topic, so we are going to cover a small portion. Here we are going to throw the few light about this artificial intelligence in robotics. That's all. So it is our focus. So please make a note. This is the concept behind this artificial intelligence. So in short, we are programming to think the robot by its own using the program like deep learning and machine learning concepts. We have several algorithms also. Okay, so this Boston Dynamics is using this technique to think their robots by its own, right? And also, and another one robot they developed. This robot is utilized in their military. Okay, the robot can fight in military instead of soldiers, right? See here, the robot can fight instead of soldiers. This much of technology they're having in robot. We have this scope of robot, right? And these robots are generally used in industries. Like we will see about the industrial robots. This basic industrial robots means, see, we have a specific area. See, if you're studying robots, and if you're coming to the class of this robotics internship, okay, you are not going to build your own robot for your home, right? Generally, this robots is used in industry to make the factory automation thing, right? So to make the factory automation, we are using this robots. Okay, so for this, we need high precision and accuracy. For high precision and accuracy, we are not going for Arduino or other type of robots. If you are using Arduino, then you can get or you can fabricate a robot, but in industry, they are using programmable logic controllers, right? Programmable logic controllers. We have a programmable logic controllers company like Amron, Siemens, Mitsubishi, etc. So now I'm going to tell you about Mitsubishi robots. Mitsubishi robots. We have a Q series, R series, I series robots, right? We have a Q series robots, Q series, and we have the degrees of freedom also. Degrees of freedom. Okay, we are going to use this. Siemens and Mitsubishi is famous for developing industrial robots. This is industrial robot. We are having this robots in Sri Ishwar College of Engineering. So in our Ignite Accelerator, so we have a special lab we developed for this robot, and it cost around 75 lakhs. Right? We bought this robot to exhibit the programming and so other skills to the students. Right? We have a Q-type controllers and D-type controllers and others. Right? See, in this robot, they are not using Arduino or other type of controllers. Instead of Arduino, they are using another one controller. It is called programmable logic controller. See, why we are using programmable logic controller means to achieve high precision and high accuracy. So we are using programmable logic controller. This PLC is durable, right? See, this Arduino is not durable. If you are doing this Arduino program continuously for 5 hours, then it may collapse, right? but in PLC it is durable, so they are using, and the cost is very high for PLC, right? Say for example, if you're having the PLC of Q series or this R series, then the cost will be around 2 lakhs, right? So it's high. Now the heart of this robot is this controller. It is like a CPU, right? This is the programmable logic controller. We have a Q series, R series, and other robots. See, it is a robot products. Okay, this is programmable logic controller. You can also program this PLC using another technique called as it is called as ladder logic circuits, right? So you can program this PLC based on your requirements. Okay, this 6-axis robots is not utilizing artificial intelligence. It is highly complicated. I told you just for the knowledge, right? But this 6-axis robot is only used for industry for pick and place operation. 6-axis robot. Okay, it has 6-axis means it is the degrees of freedom. I will tell you the meaning of degrees of freedom later. Please wait. Okay, now this is a CPU. It's a CPU of robot. See, I told you already. We have a PLC. In this PLC, we have see when the PLC first we have to program it. Then it will work based on the program what we gave inside the PLC. So next is this is the D type, and we have a Q series, R series robots. Please wait. Q series PLC. They are the standard manufacturers. Okay, standard manufacturers of Mitsubishi. We have the basic components of PLC inside the CPU. It is like a computer. I told you already. Inside the CPU, we have a this modules. It is CPU base unit, power supply, then it is input output module, next is analog module, simple motion positioning module. So these are some modules they're having, because using these modules you can connect another machine or another robot to one robot. See, using these machines, using this connection modules, you can connect one pick and place robot to another module through internet, also through cloud. See, this concept is formulated, and this concept is coming in the concept of industry 4.0, right? So you can connect, say for example, a participant having a robot in Delhi, right now, and another one participant is having the same robot in the South India, Coimbatore or Chennai, right? So the participant can communicate, or he can give the signal, or he can give the code from Delhi to Coimbatore using this input output and this modules, right? He can give using this. See, this module is called as information or networking module. He have to connect through internet, right? Or in-house, he can connect using the LAN also. Say for example, in your college, you're having the computer laboratory. This all the computers are connected. This all the computers are interconnected using LAN. This is called as local area network, LAN. Okay, you can connect through LAN, or you can connect through internet, cyber, cloud. Okay, so we are going to use this. So these are the components used for PLC. It is called as Mitsubishi Electric. So it is the standard manufacturers. So also Siemens is also the standard manufacturers of PLC. They are using this Q series, R series, L series, F series robot. This series is called as versions. See, it is called as some variants. Based on this variants, they have the facilities, right? Facilities, right? They are giving some facilities. So here they have disabled some facilities in L series. Here they have disabled a few more facilities in F series and R series, so on, right? So based on the facilities, they are charging, and so it's having some facilities. No, okay. So it is a base unit, and it is a power supply, input output modules, analog modules. Okay, so these are all some few concepts behind the industrial robots. So please know these concepts also, right? Okay, now in this session, here I gave some idea about the industrial robots and other things, right? And about the Boston Dynamics and AI deep learning, machine learning also. Okay, now I'm going to tell about another one board similar to Arduino, similar to Texas Launchpad, similar to Arduino Lily, and similar to Siemens and Mitsubishi Electric PLC. I'm going to give you another one board name. Maybe see, you didn't hear that word, right? It is Mac 3. It is Mac 3 CNC controller. CNC controllers, right? It is the board. So it is cost around 3,000 rupees. Right? So it is Mac 3. This is a board. You can control the 5-axis machines, 5-axis milling machines. So here you can control. Right? This is a device. Okay. So in this, you can control the CNC machines. It is not coming under purely. It is not coming under the robotics, but it is a basic behind the robots. And is basic behind the industry automation, right? Because in industry automation, robotics is a sandwich to each other, right? So we are using this Mac 3 board. You can search the software also. You can simulate like Tinkercad, right? You can simulate like Tinkercad. This is called as Mac support. Mac support. You can have the CNC software. Search in internet. Don't go outside. Search in internet. Have the sources, right? Software. Here you can simply you can download this. It is called as Mac 4. This version is updated version, so it requires some drivers, right? It is coming under factory automation. Okay, so here you can download it, then you can simulate it up to certain level, right? So it requires the simulation plugins also, so you can download it in this site. So it is freely available, so it is freeware with certain limitations. Okay, now try this Mac 4 for free now. So it is free simulator, you can do it now. Okay, so here you can use this Mac 3 board for simulation and use this for industrial automation and for digital manufacturing. Okay, so you can search it. And so in this session here, I'm going to give you some other points, how to buy the products and how to do the projects using this Arduino or other microcontrollers. And I will give you some other information about the storage or e-library. Okay, I'll give you the information about e-library. It is ThinkIverse. ThinkIverse. Go to ThinkIverse. I told you already in my first day, I think so. This is a ThinkIverse. It is a huge repository. Go to this. Here I have already my Tinkercad and this ThinkIverse account. You can use this ThinkIverse website to download this concept. You see it's a parts. It is developed by some other person, and they shared in this cloud platform, right? You can search also robot. You can search this. You can use this 3D models to take printouts. Okay, this finger grips, right? You can give this arms and other things, right? Here you can search this. This is the simple pick and place robot. Okay, so as our SAR told already, you simulated the Tinkercad and you are going to use this Arduino. Okay, we developed a small pick and place robot. Okay, I will share the link shortly, right? Please wait. Please wait. I will share it. Okay. Okay. Can you able to see my screen? Can you able to see my screen?
No, sir.
No, sir.
No, sir.
No. Oh, please. Okay, no issues. I will share it. Please wait. Please wait. I will share it. Okay. will share it. We gave a pick and place robot to the students. We are giving the training to the students. I will share that video to you for your better understanding. Okay, please wait. I will share that video. Please wait. I am giving the link to you. Yes, I will share my screen. Please wait. Is my screen visible now?
No,
No,
sir.
sir. No, sir. No, sir.
No, sir.
No,
sir.
No, sir. Yes,
Yes,
sir.
sir.
Sir,
No.
visible.
Okay. Actually, now we developed this. I will skip this session to this pick and place area. Yeah. See, this is our own developed robot. See, this is our own developed robot. It's a pick and place robot. We have a simple Arduino board, and we have the servo motors, right? Servo motor. See, it is not a stepper motor. I will tell you the difference between servo and stepper later. See, it's a huge area. Okay, we have a controller. We have a controller, and we have a servo motor here. We have 3 servos, so it is a 3-axis. 1, 2, 3. Now we have see here we're having a servo motor. Here you can give power and you can give the signal from this controller. Then it will run based on the program. Okay, then it will pick and place an object from one place to other place. Okay, and see here you're having a gripper, as our sir told the basic parts of the robots. Here having a gripper. See, it is a gripper part. We developed all this gripper part, this arm, this base part. So in our own college, we have a separate space to create these robots, right? So we have a CNC based laser cutting machine and a 3D printing machine to develop this type of robots and for these machines, right? So you can develop by your own robots using this concept by programming this. If you know to program these controllers, then you can develop your own robots. It is our aim. So it is our object. So we are telling about the programming of Arduino. So we are simulating the program using Arduino. Okay. Now, how you can do the projects? Okay, you can do the projects. You can download this objects, then you can take print out and other things. Then how you can do? We have another one website. Please make a note, students. Okay, it is Instructables. Go to this Instructables and searching this, right. Then here also I'm having this account. Okay, this all websites I'm having account. Okay, you can search this login. Okay, having account to Google, you can search it. Okay, go through the Gmail account. Now you can search for projects. Our several projects. You can make the 3D printer. You can make a robot. Everything. Searching. Okay, let's search. You can do your project. Then you can upload your own project. Okay. See, actually, I uploaded this project to this Instructables with code. Simply, you can copy the code also. Okay. Just copy the code and this drawings design. I uploaded this all these designs and pictures in this Instructable. You can copy this code from our Sri Ishwar College of Engineering laboratory and the code. You can do this copying operation using this Instructables, right? Okay. Pick and place robot, no? Pick and place robot. Okay, I'm having the searches. There's a search results. You can do the searches, right? We have some instructions here, right? You can do this, searching this. You can do the projects. You can do the projects for your own. Okay, you can do these projects. You can do projects using this Arduino. This is called it is called SMPS. It is switch mode power supply. and there's a driver. This is a stepper motor. I'm going to tell you the stepper motor and the servo motor difference later. Okay, and this is the instructions and this is the components required. The instructions and the components required to fabricate this pick and place robot. Okay, and this is it's a circuit connections, and it's a firmware. It is a software you're going to use, right? They gave all instructions. Please read carefully, and you can search several projects. If you're having your own creativity, you can do your own projects. Then you can upload in this Instructables website, howtomechatronics.com. We have such a lot of websites to make this, right? You have the designs also. With the designs also, you can make the gears, right? See in this gripper, you have we have a gears, right? See this gear also manufactured in our C. Ishwar College of Engineering laboratory, right? So we have all these instructions for doing the fabrications of robots. Okay, and I'm going to tell you another one concept and the terminology. It is Arduino EY. Arduino EY. Some terminologies may be new to you. Please listen carefully and search in internet. This is Arduino EY. This Arduino EY is similar to Arduino, but it has a provisions to program, and it has so many peripherals, right? It is a starter kit. It's a total starter kit. It's like a tutor, right? Beginner, it is very useful, but it's cost around 10 to 15,000. So it's a starter kit. Okay, so it's a beginners. So it is for beginners. Okay, based on the programming concept, it may vary. It depends upon the robot you are creating. Okay, so we can create a robot using PLC, Arduino type of microcontrollers, or it may be Raspberry Pi. Okay, whatever may be, you can program. I hope you can understand what I am telling, and you can download the codes also. Codes. Okay, so this is the concept behind the do-it-yourself, DIY. So it is shortly called as DIY. Hope you can understand this, right? So please make the note of this terminology I gave. Okay. So students, do you have any doubt? Some of the time is 10:55. You can give your chat, right? You can give your clarifications. I will. Yeah, somebody is chatting. Really good. I am diploma student. I think it helps in BE also. Pralhan, exactly, bro. It is a Pralhan, Kansas. Okay, thanks for internship. Sure. Okay, don't give a feedback now. So now give your clarifications or queries, right? So please give your queries here. Then we have a separate time to give feedback. Explanation further about embedded systems, sir. Yeah, sure. What coding they give for robot operations? Santosh. Santosh, what coding they give for robot? See, if you are using Arduino, then you are using C. See, I told you. So it is called as embedded C. Right? Or if you are using PLC, then you should use the type of program called as programmable logic controllers. We are going to use, it is called as ladder logic program. So this type of techniques we have to use for programming, right? It is coding. Okay. Salman Chaudhary is asking, sir, how can I get the parts of pick and place? Don't worry, you have to build your own. You can cut through acrylic sheets or you can cut through plywood. See, because pick and place means you have to concentrate in all things. See, it means you should have the very, very light material and the cost should be low, no? Okay. So you have to use acrylic sheet and you have to cut the sheet. So it is based on the requirement. Then you can build your own robot. Try it yourself, right? Don't worry. So in future also we will give the technical support to you. Okay, Salman Chaudhary. Hope I cleared your doubt, Salman. Okay, Salman Chaudhary. Okay, thank you. Okay, sir. Thank you, Sulit Kranga. Then where you then where the Python coding is used. Python coding, okay, so it depends upon the controller if you are selecting whether the coding is through Python or C. If you are using embedded C, then you can use it for programming the controllers. It's like arduino. If you are using Raspberry Pi, then you will go for Python. Okay, so it is the difference between these two things. And if the pick and place robot does manually coding, yeah, you can do the coding manually. Okay, then share your feedbacks. Yeah, so yeah, students. Then difference between C and embedded C. Okay, C is a common compiler. Then you can give your simple arithmetic operations or simple your data operations and other things. But in embedded C means you can use the C to program a hardware, right? Please listen carefully. You can program to actuate a hardware. So it's the difference between embedded C, and this concept is coming under MEVL as a design or in BE. Okay, thank you. So now students, you can share the feedbacks now. Now it's a time to give the feedbacks. Thank you, and please stay here. We will take a group photo in the final session. The session is amazing knowledge for free. Oh, okay. Thank you. It's not. It's our pleasure. Okay. Chat is running. Salman Chaudhry, thank you, sir, for new knowledge about robots. It's a very good class. Saiba Venkatesha Krishna, thank you. It's a very good class. Dakshin Ravindranath, okay. Excellent session. Good informative. Thank you for sharing. Okay. Thank you very much. How to put attendance? Don't worry, we will retrieve your data. See, because the session is recording. Okay, I forgot to stop recording, please.